Okay, so we are looking at logic and mathematical proofs. Logic and mathematical proofs. So we are going to this is discrete maths. So we are going to start with under logic and mathematical proof. We are going to look at propositional logic. That's going to be our first topic. Is propositional logic. So this is where we're going to kick off this chapter. So under propositional logic, we have to define what is a statement or what is a proposition. So a statement we are saying a statement or a proposition is a declarative sentence that can be either true or false. Declarative sentence that could be true or false. Or you can just explain it as declaration of fact. A statement is a declaration of fact. Okay, so for an example, if I give you a mathematical statement whereby I'm saying the magnitude of an empty set is equals to 0. So this means this is a true statement, isn't it? The magnitude of the empty set is equals to 0. Usually that's how you represent it. Empty set is equals to 0. The statement is true. So proportions are denoted using different notations, whether it's an uppercase or lowercase, and they have different meanings. So when you are denoting a statement, we can denote proposition using capital letters or uppercases. Proportions can be denoted using uppercases, P, Q, R, etc., depending on the text that you're using. And also, but they have a meaning. So when you're using lower cases, we use lowercase letters. Normally we use P, Q, R, but they can use any. These are general statements. These are general statements or propositions that have no meaning. They don't hold any meaning. So far we just looked at the definition of a statement. That is a declarative sentence that can be either true or false. This is very important, or a declaration of fact. So this is our example. Just using a basic example, and then we are saying the notation for propositions. When you're using lower cases, we're just representing general statements that has no meaning. So now let's dive into the logical operators for propositional logic. So the logical operators that we're going to focus on, operators are subdivided into categories. We have the urinary operator. These ones act on one proposition. They act on one proposition. And an example of this operator is the negation operator. The negation operator, which we represent using this sign. It's one example of a unary operator. And then secondly, we have the second class, which is the binary operator. So in binary operator, we are saying binary operators, they act on two propositions. They act on two propositions, and the basic examples of these ones, we have the conjunction, and also have the disjunction, it is etc. So there are many, but we're going to look at them individually. And then we also have as an example here what we call implication. The implication operator. Also what we have called the implication operator. The implication operator. Implication or biconditional implication. It's actually and the biconditional operation. So let's start with the negation operator. So what is the negation operator? The negation operator, we said it's under the unary operator. So we have the negation. We're looking at the negation operator. A negation operator, the meaning of this one, the meaning of a negation operator, it's not like I'm going to expand on what not means, but this is the basic meaning. It's not, and we use the symbol. We use this symbol to represent the negation operator. And then what is the meaning or the description of a negation operator? A negation operator reverses the true value. It reverses the true value of a statement. It reverses the true value of a statement. So let me just make a simple example so that I can show you how it works. So let's say let the statement P implicate that 4 plus 4 is equals to 8. And then the negation of statement P will implicate that 4 plus 4 is not equals to 8. So that's how it is. So this was the true statement, whereby we said 4 plus 4 is equals to 8. But the negation of these statements will imply that 4 plus 4 is not equals to 8. So it reverses the true value. It was true because of this equality sign, but then it reverses. Now it's no longer equal. We are saying 4 plus 4 is not equals to 8. That's how the negation statements work. It just reverses the true value of a statement. So let's use the truth table. Let's represent this using the truth table. So if you're using the truth table, we're going to have any proposition, we're going to have any proposition that can be true or false, right? Any proposition that can be true or false. And then we are saying if we negate that proposition, if the proposition was true, then it's going to be false. If it was false, it's going to be true because it reverses the true nature or the true value of the statement. So this is the true statement for negation. So we are looking at the second operator. The second operator, we have the conjunction. We have the conjunction. With the conjunction. So with the conjunction, we have the meaning of a conjunction. We use and. So also the symbol this is the symbol that we use for conjunction. And then what is the meaning of a conjunction? How can we describe it? So this one is true only if both statements or both propositions are true. It's only true if both propositions or both statements are true. So let's look at a typical example for this one. So let's say P is equals to a statement that says it's raining, right? And then Q, it's another statement that implies that it's cold. So with this one, this is supposed to be true only if both statements are true. The both propositions have to be true in order for P and Q to be true. So this one is going to be it's raining, and because we're using it's the end of it, and it is cold. And this is basically true. When it's raining, it's cold. So both statements were true logically, so that's why this is also true, right? That's why you're saying P and Q is also true. And let me look at a more mathematical example whereby you're saying P is a statement 12 is divisible by 3. This statement is true. And then another statement Q, we are saying 3 is a prime number. This statement is also true, right? So now P and Q, it's what? 12 is divisible by 3, and 3 is a prime number. 3 is a prime number. And then this is also true. Why? Because these two statements are true. Remember, this is what we said. We said true if only both statements are true. So now let's look at the truth table for this operator. So we have two statements or two proposition P, Q, right? So and then we have P and Q. So if we are looking at this one, we have the P statement can be true, true, false, false. The Q statement can be true, false, true, false. So now I've catered all of the combinations: true, 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 false, false, true, true, false, false. So now let's look at how the operator is applied. So we are saying only this operator is true only if both statements are true. So the P statement is true, the Q statement is true, so this is going to be true. The P statement is true, the Q statement is not true, so this is going to be false, right? So also here we have false, so this is going to be false, and false, false, they are both false, so it's false. So this is the truth table for the conjunction operator. So now let's move to the third operator, whereby we are looking at the disjunction operator. We represent it using this symbol. So the meaning for this one, it's or. The meaning for this one, it's or. So the symbol we use is this, I've already shown. And then what is the description for this one? We are saying it's true if at least one statement is true. This entire operator is true if at least one statement is true. And as you can see, it's inclusive. At least one statement is true, it's inclusive. That's what is special about this one. So let's make an example. We are going to have, let's say P is a statement that says I will study, and then Q is a statement that says I will play. You can only do one of these can only be true, right? And if you decide to play, which means you won't study. If you decide to study, which means you won't play. So one of these statements is true. So we are saying P or Q. P or Q will be what? I will study. If you decided to study, I will study or play. You can either do one of these, which means one is true. So another example that I think you guys will appreciate, especially for this one, we can say let P be a statement 2 plus 2 is equals to 4, and Q be a statement 3 plus 3 is equals to 5, right? So we have these two statements, and then we are saying P or Q is equals to what? 2 plus 2 is equals to 4, or 3 plus 3 is equals to 5. So this is a statement. And one major application of this operator is in set theory. When you're looking in set theory, where we are saying let A B. Remember, in set theory, if you're using the union of elements, this is or, right? So that's what you're going to do. Let A be a set of even numbers less than 10. So A is equals to 2, 4, 6, 8, and let B be the set of multiples of 3 less than 10. So B is equals to 3, 6, 9. B is equals to 3, 6, 9, which means A union B is equals to 2, 3, 4, 6, 8, 9. So this is, if you look at if you are looking at, do we have an intersection? Yes, we do have an intersection, which is 6. This is A, this is B. A, you have 2, 4, 8. B, you have 3, 9. So the union of these, we are looking at the combination, right? So this is the union. When you're looking at the set theory, is basically an application of the disjunction operator. So now let's look at the fifth operator, which is implication. We are looking at the implication. So the meaning of the implication is if, then. So the symbol of, obviously I'm going to explain what that means. So the symbol that we use for the implication is this. This is the symbol that we use for implication. Is this or is this? So these are the two symbols that we use for this. So and then what is the descriptive? What is the meaning of the implication? So we are saying this one, it's true except when P is true and Q is false. So, okay, so let's look at an example for this one. So if you're looking at an example for this one, we are saying if X is greater than 2, then X will be greater than 1. So this is one way of looking at it. Or we can just use P and Q, but either way. So if P is greater than 2, then P is also greater than 1, right? It's true, because if X is greater than 2, by default it's also greater than 1, 0, and all the negative numbers. So this is one way of looking at it. And another typical example that we can use, we can say if A is a multiple if A is a multiple of 4, then A is also even. It's also an even number. All multiples of 4 are even numbers. So this is just a typical example of the implication operator. So let's look at the biconditional implication operator. The biconditional. So with the biconditional, the meaning for this one the meaning, it says if and only if. So the symbol for this one we use, this is the typical symbol that is used. So what is the description? We're saying it's true when both propositions, it's true when both propositions have the same true value. Both true or both false. Okay, so let's look at the example for this one. So with this one we can just use the truth table. To kind of illustrate this. So proposition P, proposition Q, proposition PQ, and then the operator P. And then we are saying we have if for P we have true, false, and then we account for all of the combinations. True, false. So now what is going to be this? True, this is going to be true, false, this is going to be false, because we are saying both should be true, both should be false. So this is also false, and then this is going to be true. So this is the biconditional operator. We can represent it using the truth table. We are saying, so with this one we are saying the meaning if and only if. This is the symbol that we use. So true when both propositions have the same true value. So when they're both true, or when they're both false. So other than that, everything else is false. So when they're true, the proposition is true. When they are false, the proposition is true. But when it's false, true, it's false. When it's true, false, it's false. So this is how you can use the biconditional operator. So on the next video, we're going to be looking at precedence of logical operators and the logic laws, whereby we are going to dive into the absorption distributive law, De Morgan's laws, identity laws, etc.